Hello everyone. Today we'll be talking about TripCalc. This is one of our most popular web apps. We've got more than 2,000 projects on the server, and I think it's worthwhile to go through it just to make sure everybody's using it the most. First things, you go to RKALC website, to sidebar, to TripCalc suite, and click on TripCalc to get the um, user interface there. The example we'll be having is a sample building that looks this way. Um, 45 or 46 meters is the total dimension of the building. You've got straight walls, you've got core, you've got normal columns, and we will be modeling this using TripCalc. So first things first, we need to find the plan. So how you do it. If you might have like a very big drawing that includes the building and together with other buildings. So what I recommend that you screenshot the plan and put it on a fresh A3 or A4 sheet in a landscape orientation to match with the user interface, and extend the building from as much as you can from left all the way to the right. So while tracing things will be super easy. Now we'll do that. So I've prepared this plan beforehand. We just go and click on PDF and find the drawing, which is on this folder. So the plan to trace is this one. I just say okay. Now what you will enter to the calibration mode. So you don't do nothing here except for calibrate the scale. So you've got here one dimensions. I prepare here forehand between two arbitrary points on the same PDF. That is just to tell you what is the scale of the drawing. So I'll go from this point all the way to that point and write the dimension 45.85. Sorry, you can click it again. 45.85 or 89, and say OK, and then finish calibration. So now we've finished calibration. The screen is now all good. So just to verify, this dimension here is 45 point something. Everything is fine. Now what we will do, we'll be doing, you just look at these two toggles. One is to turn off and on the drawing, and one is to a dimmer. So in case you wanna see it darker. So I'll make it light, and then click on the slab. While on keyboard, just hold on shift to get like vertical or orthogonal lines. So click on the corners. Now here I made a mistake, so it doesn't matter. So you can start over because you are only allowed to draw one slab at a time. You go there. There is a notch there in the plan. Go straight lines. You don't need to be super accurate. That won't make any difference. And double click to finish the polygon. So now we've got the slab. Click on home. Now we want to trace, so we just make it slightly darker. Start with whatever you want. So let it be the core. You don't need to draw the internal walls because the core is all one unit. Draw the walls. Use shift to do vertical and horizontal lines, and that is the other core. Now I go to columns. Just try to make it at the center. TripCalc is a very useful tool to size up the columns at the beginning of the project in the scheming stage of the project. You can also use TripCalc to export the file to DWGs, DXFs to model it in ETABS or FCalc if you wish. So now we are done with putting all of the columns and the walls. So you just put the total ultimate KPA. This one should include the slab weight, superimposed load and live loads. You need to put the column weights, anything or if the building is so tall, like the vertical component coming from vertical elements is too high, could be up to 30% or 35% of the building is very tall. Now we'll put 13.5 here. I can go through the calcs, but that should be a good start for any project, and 20 stories. So that is what we have. Now we click on this, the analysis menu. So you've got all of the columns now calculated, calculating the loads, the tributary area, and the schedule of columns. So that can be used to compare against ETABS or Strand or any other software to make sure that you're doing the rundown right. Because relying on a 3D model per se is not enough to get upper and lower bounds for the column loads. Sometimes shortening of column is too high in the model, which is not realistic, or you have so the loading redistributes. So in some scenarios you might get some of your columns not working, or if the column is landing on a transfer slab, so the dipping effect could be adverse. Now you can at any point click on this one to see what is happening in the background, but we are all good here. Now, next step is optimize columns. So just going back to our agenda. So that is the plan. There is a flow procedure here. As I mentioned, you prepare the plan first, import the PDF, trace the elements, and then analyze and review. And then you go to column optimization. So rather than taking all of the columns to Excel sheet and designing them using your own workflow or design them one by one. So I've got all of the column loads here, 9,000, whatever, 11,000, etc. So click on optimize columns. Now, what is the target F prime C for that 20-story building at the level 1? Let's say 65, because it's a lot of loading there. And whatever the column height, just put it as default 3 meters, or if your floor to floor height is 3.15 or 3.2, whatever. And what is your target percent? I would always recommend to start any project with a target percent of 1 and maintain that as long as you can, because when the project goes into construction stage, sometimes you will need to increase the reinforcement. But if the project starts with the screaming columns on 2 and 2.5 just to please the architect, I don't think that would be a wise idea. So we've got F prime C, height, target percentage. Now you can start with initial width. So let's say this column, this one here is 11,000, let's say 350. We've got another column, this one there, 5,000, so make it 250, let's say, and then run optimizer. So now it will be doing, it has now calculated all of the other dimensions that needed to get 1%, 3 meters, 65, and 300. So apply and redraw. So what you see on the background, all of the columns have been designed in a single click. You can also go to change any column to any shape. For example, that if that needs to be a circular column, let's say, and then work out how much diameter you need. So it needs 825, for example, and so on. So you can, at the end, print the report for optimization with the assumptions, all of the columns. Now, there is one thing. If you want to review, let's say, this column here, click on that icon. So it will take you to our column calculator web application. So it will take the same numbers that you've got here. What is the column that we've taken? 11,000, the 11,000 column loading there. So it will tell you how is it working at 80% on one direction, 69 on the other, which is the long direction, and that is the biaxial. It's designing the column for single curvature, which is very highly recommended. Now you see there, we always assume the smallest diameter. So, but what matters here is the 1%. So if you want to change the rebar to 20, for example, and make it, let's say, 9, or here you need 10 bars at 200 spacing, you will end up with the same result. So what matters is only how much real percentage. At the end of the day, you've got it all. I've spent in the past many hours just doing this very simple task that we finished here in 5 minutes tops. So you can use this in your projects, and you can do it at stages every 5 floors and similar. So now what we do, just like save. If you are very curious, I'll save this on a desktop, call it RKALC plan, and you can also review if you are very keen. Go to RKALC or take it to ETABS if you want. So there is here file, import RKALC plan from the desktop. A single click of a button, you've got the building already imported. So what you can do, just like apply KPA on this whole floor plate at dead load. So what we have 20 levels times 13.5. So that is 270, although notorious. You can apply such a load on a slab, but just for the sake of verifying or comparing the numbers, just do that, apply, and then just exclude the on weight, although it's not significant, and in RKALC just design or like analyze the structure, and then you can see what is happening there on a 3D. So that is the whole structure, and if you want to look at the loads and show values, so you'll see there, let's say we have a column here 11,655 for example, and here you've got 12,280. Let's take that one, 12,500, 12,400, and that makes a lot of sense. Sometimes you've got big span and small span, so the tributary area method or Voronoi diagrams will not be always valid. That's why some people do the run down using RAM concept or say for single floors. I guess this concludes the example. You go to, I've written all of the steps so you can use it. Most important is to spread the plan across the page, and you will find it in the learning center, which is by clicking on this one there. You'll find the same example published there together with this video. This concludes the example. Thank you very much.